Hello everybody and welcome to this video on properties of limits. So how exactly can you use multiple different limits and set them up so that it's easier for you? Well, I'm going to list out the major properties that limits have. You have the addition property. You have the subtraction property. Then you have the multiplication one. And obviously then you would have the division property. And lastly, you have the property that deals with exponents. So these aren't exactly the official vocabulary that is involved with these properties, but for the case of this video and for future purposes as well, you won't ever have to actually state what property you're using. You just have to show it. So this is more implicit. Let's start off by looking at an example using just variables. So here we will take the limit of a function. Let's say the function is f of x as x approaches a value a, and then we also have another function. We'll call that h of x. So we have two functions that are being multiplied in this case scenario, and now we're wondering, can you actually divide these two functions into separate limit equations? And the answer to that is yes. So you have to make sure that your limit is not discontinuous at the value that you're checking for. In the case we're checking for a, right? So we have to make sure that it's not discontinuous on both. But in the case that we have something show up where we have 0 plus d and e, or does not exist, or something like that, we can assume the value is 0 of that limit. Same with when you're multiplying it and dividing and so on and so forth. But it's important to make sure that the value itself is real. So what I mean by that is you can't divide a number over 0. So similarly, you can't say d and e over 0 exists, because obviously it doesn't exist. But for example, if we were to say 0 divided by d and e, that would actually equal 0. So it works out that way. You can manipulate 0 and d and e, add, subtract, multiply, divide them, and at the end of the day you'll get the value back of 0. So that's something to note and to keep in the back of your mind. Now let's take a look at this. And how can we split this? Well, easily we can just say limit as x approaches a of f of x times limit as x approaches a of h of x. And we can just multiply those out. So let's say, for example, we were getting the value of 3 here and 6 here. We can multiply them and get 18, and that works out perfectly. So we're allowed to do that, and that's one of the properties, like I mentioned with the multiplication property. Now let's go on to a different example where we just have a constant outside. So let's say, for example, I'm trying to find the limit as x approaches a of 3f of x, or something like that, where you have a constant that's present in there, but it doesn't actually relate to the whole equation. You can factor it out if it is already in there, but if it's not in there, you can easily take this 3 and put it on the outside. So you can say that this is equal to the 3 limit as x approaches a of f of x. So you can also state it that way, and it should work the same. So that constant doesn't actually play a role as long as you multiply it back in at the end. Now let's talk about the dividing property that I was talking about in the beginning. So how can we divide? This is also similar, where we have limit as x approaches a of f of x, and then we have h of x. Well, we can do the same thing where we can find the limit individually for both of them. So for example, I can move that up and say limit as x approaches a, and then just divide them both out so they're both limits are divided, and that would also work out. Now this is also the same throughout all of them, so I can add and subtract the same way. So if I were given limit as x approaches a of f of x minus h of x, I can split this limit into two. So I can say limit as x approaches a of f of x minus limit as x approaches a of h of x. So both ways work out, and it's also the same if I were to add them. So that would also work out correctly. And lastly, let's look at our exponent property. Now, what if we were given an exponent for our limit in our limit function? So let's take a look at that. So let's say limit as x approaches a of f of x, and now we know that it's raised to a power, let's give a random value of 5 maybe. Well, we can manipulate this limit and say limit as x approaches a of f of x, the whole thing to the power of 5. This is because if it were to be continuous, when you plug it into the equation, when you plug in your a value into your f of x, you're essentially doing that first before you do your exponents. So this works out in the same way because you're technically just plugging in over here on this step, and then you are finding the exponent there. So that's about it for this one. And just make sure that you have memorized these properties and you know how to apply them in any case. And also notice that all of them have the same x value that it is approaching, so they all have x as approaches a. If it were approaching a different value, none of these properties would actually be in existence. So make sure to check that and apply these properties when necessary.